This page. All right. Have you tried it yourself?
Mm-mm.
I haven't tried it. Let me see. Which one we're supposed to do? 2018. All right. Let me look at the review here. Specifically just part D. All right. So here is number 4, 2018, part D, which once again, if you look at the Google Drive, you should have the link to it there. There's annotate. All right. So they gave you the height of the tree is modeled by this one right here, or we call G. And X is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter base of the tree is increasing at a rate. So the diameter of the base tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time? So as you can see, you want to know the rate of change of the height of the tree, which is, I would normally put dH over dt, but they don't use h for height. The height of the tree is represented by the function of g. So instead of that, what we're really looking for is dg over dt. That is what we're looking for. All right, the height of the tree. So that is very clear that when you look at this function right here, you are going to have to find the derivative. So to find the derivative, do you know what you have to do on the right side here?
The quotient?
Yes, you have to do the quotient rule. So I got to take the derivative of the top. Now don't forget, you took the derivative of the variable x with respect to time. So that's u prime v, I'm just gonna copy the bottom, minus v prime, which is 1. But once again, don't forget, you took the derivative of x with respect to time. That's v prime times u, which is the top only, exactly as it is, all over the bottom squared. So I'm sure they'll give you some credit for getting that far. All right. And our goal now is to simplify it. Now, if you notice, they have dx dt in common. Oops, that changed the color. They have dx dt in common here and here. So I would actually factor that out just to put it out here. I still have 100. I have to distribute that to this parentheses. So there's just 100 plus 100x minus, I got this is already gone because I already factored that out. And then I still have 1 times 100x, which is just 100x all over 1 plus x squared. Now you didn't have to factor it out, the dx dt. You could have left it in there if you wanted to. But I want to show you the 100x minus 100x will cancel each other out. So you're just really left with 100 on top. So I just have 100 over 1 plus x squared dx over dt. Is that what I really have? Do you have questions?
Mm-mm.
All right, so from here, all we get is plug in stuff to finish it off. So do you know what x is?
50?
Oh, I put the square in the wrong spot. The x is 50. I agree. And do you know what dx dt is? So what does x trans?
0.03.
Huh? What is it?
0.03.
That is correct. The 0.03, and let's make sure it says increasing, so it is positive. You gotta watch out for that. Because if that's decreasing, then you have to put the negative sign yourself. So at this point, you understand you can stop. You don't have to actually find the exact answer here at the end. You can stop right here at this moment, because do you agree that if you take this answer that what we have so far, you can actually plug that in the calculator and get an answer, right?
Mm-hmm.
All right, it'll come out to a number. So this is already acceptable as an answer. All right, and they didn't say anything about units, so I'm good. That's it. We're done with part D. When I looked at it, that was worth 3 points. 2 points for getting this right, and then 1 point for getting this right, the final answer. Oh, hold on. Why'd you put 50 anyway? Oh, wait. 50, sorry. This is not 50. You put 50.
Oh, it's not.
It's for the, where's 50 at? 50 is for the tree, how tall it is. 50 is for G.
Oh.
That is not for X. So you gotta watch out for that. Just because it's 50, that's for the tree. Remember, height is multiplied by the G. So G is 50. That's what they gave me here. Now, X is the diameter of the base of the tree. So that is what I need. So 50 is not actually X. 50 is for G. So how do I figure X?
Could you do wait, no, I don't know.
You have this function right here. You know, this part is 50, right?
Mm-hmm.
So you should be able to figure out X, hopefully, from there. So let's actually, let me erase some stuff. I need space. So let me do this on this side. All right, so we have 50. Oh, that's the eraser. We have 50 equals 100x over 1 plus x. So I would multiply 1 plus x to the left side, and that'll give me 50 plus 50x equals 100x, correct?
Mm-hmm.
You okay?
Mm-hmm.
We subtract 50x on both sides, and that should be very obvious to you after we subtracted 50x on both sides, that x has to be 1, right?
Mm-hmm.
So actually, this was, we're supposed to put 1 here. All right, you gotta watch out for that one. Because just because they gave you the tree is 50 meters tall, you didn't actually think about what does the 50 represent. That's actually for G, because the tall is height, which is G, not X. All right, so you gotta watch out for that one. You have any questions?
No.
Okay, so let me clear this right here. And there is one more. 2016. This is another non-calculator problem. Let's see. Let me zoom in a little bit. So they gave you this figure right here. And so it's kind of like a cone almost. And they gave you find the average value. So I said skip part B because this is not tested this year. This is on unit 8. This was unit 8, so that is not there. So what you can answer is part A and part C. So do you know how to find the average value? So they give you the radius of the funnel, which is right here. They give you an equation with a constraint. Do you know how to find the average value of that?
To be honest, I forgot.
You forgot how to do average value?
Yeah.
There's a specific formula to find the average of anything. All right, you probably, if you can take it, you probably should write it down somewhere, how to do the average value. Now, so this is one formula you should know if they ask you ever to find average, is the average of this. The average of a function, of any function, all right, in this case, it's gonna be R, is just the integral from A to B of whatever that function is. And then you're going to multiply that by 1 over B minus A. All right. So in this case, the average of R will be 1 over, and what is B and A here, you think?
Zero, 10.
Yeah, 0, 10, but the 10 goes first. 10 is the B, this is your A, and that's your B. So 10 goes first. So you're going from 0 to 10 of the function of R. And you gotta be careful of what you put on the right side. What variable are we integrating here? If you look at this, R is this one right here.
Mhm.
So we're gonna be integrating only one type of variable here,
H.
H. So that's why I put DH. Okay. So you gotta be careful with this part. How do I know it's DH? Is because if you look at the function of R, the variable, the independent variable is H. And that's why I put DH. All right. Because if you look over here, if it's X, I put DX. Your R, this R can be written as R, and depending on whatever H is, that's what your R value is going to be. So I have to put DH. All right, now remember, you're allowed a calculator. You get, and I'm assuming you borrowed a TI-89, right?
Yeah, I still have it.
Okay, so you do not have to do this by hand at all. You can literally type this in and get your answer. All right, so it's actually not necessary for you to do this by hand, but if you want to do it by hand, we can. You could have just written this down and put it in the calculator and you're done. But if you do not know how to use your calculator, then I would have done this. Technically, this was not supposed to be a calculator section anyway. You're supposed to be able to do this by hand. So I'm replacing R with whatever is up here, which is 1 over 23 plus H squared. Okay, that is just a coefficient. So that's going to go in the front. So that's a 1 over 200 really. 0 to 10 of 3 plus H squared dH, which is going to be, I'm going to go ahead and integrate. So what would 3 be if you integrate that? Carla?
Oh, sorry. 3x
The one CC?
plus 1/2.
Integrate 3 with respect to H.
Oh,
What would that be?
3h.
That should be 3H plus, then you need to integrate H squared, which is H to the power of 3 divided by 3, or 1/3 in the front. Right? And the next thing you're gonna do is plug in the 10. So all of that is when you plug in 10 minus, and if you plug in 0, that's 0. If you plug in 0, that is 0. If you plug in 0, that is 0. So I'm just going to go ahead and put 0. And once again, you can stop right here because this is something you can plug into any calculator and get an answer to, right? So you should be able to stop right here. That will give you a numerical answer. You can stop right there and we are done with that. Do you have any questions? All right. Then we're going to do part C. Part C is the last one. And we're done for the day unless you got questions. The funnel contains liquid that is draining from the bottom. So clearly it's coming out. At the instant when the height is, so when height, oh, they put an H here anyway, is 3 inches. The radius is decreasing at a rate of 1/5 inch per second. What is the rate of change of height of the liquid with respect to time? So based on this last sentence right here, they're asking for the rate of change of the height. So we're looking for dH over dt is the question. Specifically, when the height equals 3. When the height equals 3, what is dH dt? Well, we have this equation right here. If you take the derivative of that equation, do you agree that at some point you'll have a dH dt because an h is involved? All right. So the first thing I would do is take the derivative of r with respect to time, which is 1. But don't forget to put the derivative of r with respect to time because that doesn't cancel out. Now, if you want to, you could have chosen to distribute the 1 over 20 first. If you wanted to, you could have just said to make this 3 over 20 plus 1 over 20 h squared. If you want to do that, you could. All right. The derivative of this, that's just a constant number, so that's 0. The derivative of this is going to be 1/10 h, because I got to take this and multiply to that. That's 1/10. And then I got to subtract 1, so that's just h. And don't forget to say you took the derivative of the variable h with respect to time. Do you have questions there? Hello?
Oh, I said no.
At this point, you're going to plug in everything you know and look for dH dt. So dr dt, they gave it to you. The radius is decreasing, so that should be negative, at a rate of 1/5 inch per second. So that's 1/5 here. The height, I even wrote down earlier, specifically when the height is 3. So that's negative 1/5 equals 3 over 10 dH dt. Therefore, dH dt is negative 1/5 times the reciprocal of that. And that's why the final answer is negative, which you can stop here actually. Well, if you want to finish it here, -2/3. And that's inches per second. Do you have any questions there?
No.
Carla? All right, I am done if you have no questions.